Greetings, Graham Warren, working with you on the AnyLogic model for the ACG case. We've got the project palette here. We've got the palette for modeling right here. That would be, if you're building a model from scratch or, editing an existing one. The primary canvas of the model is here, and then we've got some properties on the right-hand side there. This model is essentially contained in this line here where we've got customer arrivals. And let's click on that. See what's going on here. Okay, it's not responding. I'll just pause and get it back. Okay, we're back. This is the source node where we generate customers, and just move my Zoom window here. You can see the details here. So this customers are generated according to a Poisson process. By definition, if we use this rate parameter, you can also specify the interarrival time distribution, and various other ways of entities arriving into this this model. And crucially, we've got arrival rate specified as a parameter here. And so you can see that I have a bunch of parameters listed here: arrival rate, mean service time, standard deviation of the service time. That's for valves, and then for clovers, and then the number of valves and the number of clovers. So in broad, we've got a flexible model here, which is going to allow us to analyze a variety of scenarios. We could do mixes of clovers and valves. We can pool or not pool. So the intention with this clip is to sort of elaborate the model, but then we're going to come back in the next clip and then look at how we model different scenarios using this rather flexible setup. Okay, so those are the arrivals. Then we go into a timer. And the reason we've got a timer is we want to figure out how long from the time of arrival to completions. And we're going to histogram that time. It's histogrammed right here. Also going to get a couple other graphs in here, show the valve utilization, the clover utilization. They will only have data in them if there are, in fact, more than one variable clover present in the simulation. Right, so click the stopwatch, head over into seize the server. And here we're trying to grab a valve first, or alternatively a clover. Now, just a note here, like if you do have a mix of valves and clovers, what it's going to do is it's going to prefer to go with an available valve before it goes with any clovers. So it does give priority to valves, according to the way this model is set up. And going to make some choice here, went with the valves as the preferred route if any are available. So there are two resource pools here, valves and clovers. Let's just have a look at the valve. So this is the Venus Arduinos, a special kind of agent in our simulation. And we specify here the number of valves. And that's one of our parameters again, right? Number of valves, number of clovers. Similarly for the clovers, you've got number of clovers there specifying how many are in your resource pool. Right, so these coffee requests, people essentially come in, wait until they get a server, and the server is either a valve or a clover with an attached barista, of course. Don't really think about the baristas in this simulation. We then head over into making the coffee. So this is a delay. And interestingly, so let's just expand this so you can see this language here. So it asks in this little snippet of Java code whether it is a valve. And if it is, it uses this mean service time, which is common to both clovers and valves, 65 seconds. And then if it is a valve that is being used to make the coffee, then we use the standard deviation of the service time of the valves. And if it's a clover, guess what? We use the clover one. Okay, so once we're done with that delay, we're going to release the server, which is the valve or the clover, and then click the stopwatch again because we're done. So in real life, the barista, of course, is going to deliver the coffee. That's included in the main the service time distribution is 65 seconds. I guess the main reason why there's a little bit of variability here is because it's going to be a little bit of walk, a bit of travel time, walking time from wherever they're making the coffee to wherever the client is seated. All right, so click the stopwatch. Just want to notice something here. Click on this. So this is a time measure end block, and we connected to time measure start, which is where we clicked on that stopwatch to begin with. And we're adding this to a database here, and that's how we're going to, that's the time and system database right here. And that's going to allow us to generate some of these statistics and histograms and whatnot. All right, and then we just push this this customer to the sink. That's the end of that customer. We don't want to have sort of past customers, completed customers lining up. Of course, the actual customers finish their coffee, finish their gossip, whatever, head back out into the streets of Rome. Right, so I think we've covered everything with just minor exceptions. This is a little animation. If you're on a Mac, it doesn't show up all that well because the figures that are used on I'm using a Windows box. They don't show up too nicely, but it does basically show the customers coming in and then getting service and then completing. And then this is the histogram of the waiting time in system. So that is a useful KPI or statistical object for the CX, and you're going to get a mean there. But also importantly, you're seeing what the tail distribution looks like. Nobody cares about the lower tail, right? That's fast service, but it's the high tail on the high side. How does that look? So even if you have a mean of a minute, if your worst case service is like 20, 25 minutes, that would be a deal breaker. And then we also get the distribution of the utilizations. And you can see they're really concentrated here around, well, we're going to run it shortly and then we'll see. Okay, so let's run the, one or two more things, I guess, just to note about the project. So I want to go to simulation main and notice that I have the parameters here and I've set this up for the base case. So the mean service time is 65 seconds. The arrival rate is expressed in hours. Now, just to be clear about that, show you why I'm using seconds for one. The time here is specified. Again, we have those two distributions, right? The VAV and the Clover. You can see the unit of time for this mean service time and standard deviation of service time is in seconds, whereas for the arrivals, if I click on that, that was expressed in hours. So I'm trying to keep it close to the language of the actual case. So go back to simulation main and plug these in. And this is primarily, well, this is where you're going to change your parameters. It runs for 19,000 seconds. How do we know that it's, if we click on here, well, modeling time is in minutes. Excuse me, it runs for 19,000 minutes. Now, although we have one barista sort of who scoots off and does some things with a cart, the ACG cart somewhere in Rome, the cafe essentially continues every day. And so these baristas will, there's 10 of them scheduled in the base case. They keep this place running. So now you're going to ask, all right, so what about some time off? Well, we have essentially every day 10 baristas. There would be maybe a couple extra hired so that somebody can get a day off here and there. Presumably going to work 5 days and have 2 days off per week across the board, right? Okay, so I just wanted to show you why it finishes up at 19,000 minutes. Because we're on the free version, you can only generate 50,000 flow units. So I think that 19,000 minutes is a reasonable time to collect your statistics, correctly estimate things like the waiting time, distribution, the utilization and whatnot, but doesn't exceed the sort of the limits of the free model. All right, so let's run the base case. And I want to show you the pop-up here. Okay, so let's full screen this just so we have it nicely represented. Move my Zoom stuff around again. And yeah, I'm able to see where I am in time. If I click on this gear in the bottom right-hand corner, so I'm at 29 minutes. And you can speed this up. But just watch this, going along a little bit. You can see the folks coming in waiting, and then it's going a little fast now, but let's just see if we can see it now. It's going real fast. Let's slow it down even more. So now I'm at 5x. I'm going to slow it down to half x, just so we can see well, maybe we go up to 1. So there's the customer getting, that's customer's coffee being made. You can see in this one that I have just 1 clover. What I'm analyzing here, in fact, is the base case where I'm taking just 1 barista and looking at that independent barista's operation. So these folks, the customers are arriving to this person's workspace at the rate of 24 per hour, and this barista is serving these customers at, with a 65-second mean service time, because it's on a clover, 20 seconds standard deviation. And you can see that there, 20, 65, 24, and then there's just 1. So there's 10 of them, but they all look essentially the same way. All right, so you can see our estimate for the clover utilization is there's 1,305 samples. So it's, according to this, 39.6 mean. We're far from done. And every time you run the simulation, you're going to get a different outcome. So I'm going to run this now to completion. You can see I'm also getting there's no action on the valve utilization because there are no valves. You can see this resource pool is empty, and the Clover resource pool just has 1. So there are some differences here. This 40 differs from the 39.6 a little bit, and then also from the 0.4 down here. They're all estimating the same quantity. There's just a different amount of data going in. I think this one here has, well, you can see it's got at least 1,300 samples, so it's taking that mean across more, more data than perhaps either of these two. This one here probably is just like the last 100 samples or something. Right, so let's run this to completion now. So you can see my time here is up to 19,000, and my histogram of W sub S is 1.54 with a 0.43 standard deviation. All right, now I would want to annotate this, so let's go back and do that. All right, so I want to put in, I guess, an extra column here. And insert 1 column to the, well, I'll do it to the left. Insert column to the left. Okay, so these are simulation utilizations. And then I want actually another one as well, my means. So just insert column to the left here. So simulation W sub S. So I think I got, and this is now in the base case, I got 43.43, and let's just verify. What did we get? Here it is. 154. So I'll come back and we're going to just do 3 runs to estimate these quantities. I don't want that. I want this 154. And what I'm going to do is I'm going to just put commas in there and then just collect some information so that we have everything amassed there. And then we're going to go back in and edit our transcript with the detail. All right. So in this this area where you've run, you can stop the model, and you can see that it sort of resets it, and then you can rerun it. And you need to rerun these things because it's like showing up on a day and kind of estimating performance for Well, it's for, estimating 19,000 minutes, fair enough. It's a long run, but it is going to vary, as you can see here. So now I've got 0.44 and 1.56. The queuing models are also not exact because we're using Kingman's formula. So this is, again, sort of because you're generating random numbers from distributions, you're progressively getting more accurate, presumably, in these estimates. But because we are curtailing our simulation runs at 19,000 minutes, we are going to get variation in these KPIs. So I just want to record this. You may be laughing at this and saying it looks very similar, but guess what? I'm able to generate a confidence interval for you once I've done a few runs. So this is 44. Let me just expand this, and I'm going to actually use this one here, I guess. Looks like 0.439. Okay, so 156 and 0.439. Not there, sorry. It has to go in here. 0.439. 6. We'll just do one more, and that'll be a wrap for this, and we'll come back and look at the other. So I just go in here and stop it again and run it. And it runs fast because I've set it up now. Because the last time I did this, I did a run to completion. So here, I've got 0.42, looks like 0.427. Not able to move this apparently, but yeah, 0.427 and what are we dealing with? 155. And so let's grab those three and ask Perplexity for a confidence interval. Now, you've probably done this in your statistical analysis, and it'd be straightforward to run the calculation yourself once you've put this into a spreadsheet. We'll see if this can handle this. Generates a Python program. All right, so there's the confidence interval 41.6 to 44.7, the mean of 432. The actual well, queuing, I guess it's 433 is what the exact number is. Let's just check that. Yeah, 433. All right, so that's the base case, and we will come back, look back, and let's just have a look at one more thing. You might want to make a note of the worst case here as well, along with your utilization and WCBase KPIs. And you can see that if I just click on this, very small fraction of folks, about 0.003%, are going to exceed this number, which looks to be 4.96, or 5 minutes, which you have to make a decision as to whether that's a long time or not relative to this use case. Cool. Okay, that's the AnyLogic model.